Okay, this week's lab is the simple forecast. The simplest forecast is just to say nothing changes. So therefore, this equals the one above it. And we gotta get rid of those. I'm just gonna type in spaces here because the computer's gonna fill that in anyhow. It's a long story. So here I said equal to the one above, as you can see there. Hit return, copy that down. The next easiest one is same change. Have the exact same change from one period to the next period. So this is going to equal the change, which is parentheses the most recent minus the one before that. Then we have to add to that the most recent. So the D7 minus D6 is how much it changed last time. The D7 is what we're adding it to. Note that mathematically those parentheses do not matter, and we can simplify that to 2 times D7 minus D6. I always do it this way, plain simply because I just remember, oh, same change, and I logically figure out what it is. But if you want to memorize 2 times the most recent minus the one before, that's fine. And it kept filling that in anyhow. Copy that formula down. Same percent change. Here we have to first calculate the percent change, so that's equal parentheses new minus old divided by old. That's the percent change, but it's a percent, so to convert it to an absolute amount that's changed, we have to multiply it by the most recent one times the most recent one. But that just gives us the change. Since that gives us a change, we have to add it to the most recent amount. So plus the most recent amount. Do that, and it gives us 40.26. And I've changed that so the formula is a number with 2 decimals. Copy that down. 6-period moving average. This is just going to equal the average, and you can do the average function. I am not going to do the average function because of what we'll do in the next round. I want to show you how it's similar. So sum those 6 numbers divided by 6. So we're adding up those numbers. You get 22.5. Let's change this to a number by clicking up here. 2 decimals. Copy that down. 6-period moving average. Here I'm going to do some typing. Notice that I highlight a section, click merge and center, click wrap text, click this vertical center. What we're going to be doing is an average, except instead of a weight of 1 each time, we'll do different weights. There are many different ways to do weighted moving averages. I'm just going to teach you the simplest one, although it's probably not the best one. So it's going to be, since we have 6 6 times the most recent one, so t minus 1, and that's actually whatever the variable, so I'm going to do x, and the t minus 1, I'm doing it as a subscript because it's from the previous period, plus 5 times x from the period before that, which is t minus 2, and change it back, plus 4 times x from 3 periods ago, t minus 3, plus 2 times x from 4 periods ago, t minus 4, plus 1 times, I'm just going to leave off the 1, x from t minus 5, and we could probably put in some spaces in here to make it a little easier to see what we're doing. So here's our summation, but we've got weights. The weights are 6, 5, 4, 3, 2, 1. Since it's a weighted average, we have to divide by the sum of the weights. So divide by 6 plus 5 plus 4 plus 3 plus 2 plus 1. This is the formula. Now, if we had a 7 period, we'd add another 1, and we'd have a 7 times t minus 1, 6 times there, etc. And that we divide by 7 plus 6, etc. Note that this will simplify. 6, 5, 4, 3, 2, 1 gives us 21. So up here we can do equals 6 times the previous one plus 5 times the one above it plus 4 times the one above that plus 3 times the one above that plus 2 times the one above that plus the one above that. Then divide by, if you're confident in your addition, you can just type in 21. If you're not confident in your addition, type in parentheses 6 plus 5 plus 4 plus 3 plus 2 plus 1. Going to convert that to a number and plot that. You use weighted moving average when the more recent periods are more important than old periods. So, we take this data and we can plot it. So we highlight that whole area, go to Insert up top here, go to Line Graph. I'm just going to draw it without the specific values. Move that up. Unfortunately, I'll have to make that narrower. Obviously, right now, I don't have the legend on it saying what it is or the axes labeled. If you were to hand it in, I would want you to do that, but since we discussed that on the earlier labs, I won't discuss that now. Save time. I want you to notice a pattern. The same percent change took off it's monotonic divergence. Same change, also monotonic divergence. The same value converged. They didn't even oscillate. These changes down here were before the time. 6-period moving average and 6-period weighted moving average. Notice they go up and down and eventually converge. So they're oscillating convergence. Those are the general patterns that these types of variables methods of forecasting take. There is one exception though, and that is the same percent change can take a different pattern. To do that, I'm going to change this 37 here to a 30. And I've set it up so that all these 37s will change once I hit return. Notice that they are all 30s across. What happened? Well, the same change now is monotonic divergence down. The same value is horizontal. The two moving averages oscillate and converge. The same percent change is monotonic convergence. If the percent change is going down but is still positive, the same percent change will have convergence. If, like what we originally had, it took off, then it will have convergence, and that's when it's going up. There's also a different formula that we could use for this. You can simplify this some. That's easier just to do it this way than to try and memorize it.